Okay, so our lesson that is on integration by parts. So the formula of integration by parts, that is from the derivative of the product, wherein if you will have derivative of u times v, that is equivalent to u derivative of v plus v derivative of u. Then if we are going to integrate both sides, so if we are going to integrate derivative of uv, integration of udv, then the integration of v du, so you will have the integral of uv, derivative of uv, that is equal to uv. And then you will have the integral of udv plus the integral of b du. By transposition, we have udv that is equal to uv minus the integral of b du. So, this is now the formula of integration by parts. Okay, the next example, that is the integral of w arc sine w dw. Our u here, that is equal to arc sine w. So, du that is equal to 1 over the square root of 1 minus w square derivative of w. dv that is equal to w dw. The integral of dv, that is v. The integral of w, that is w square over 2. Okay. So, let's go to our form. That is equal to uv minus the integral of v du. So, substitute u, that is equal to arc sine w. V, that is equal to w squared over 2 minus the integral of v w squared over 2 du, that is dw over the square root of 1 minus w squared. So, this form, w squared over 1 minus w squared, this is a form of what we have discussed on trigonometric substitution. Okay, we will solve this one by trigonometric substitution. So, the integral of w squared dw over the square root of 1 minus w squared, by solving using trigonometric substitution, we will let w is a form of sine theta 1 a minus u square. So, sine theta. So, derivative of w, that is equal to cosine theta d theta. So, we have therefore we have from here the square that we can form, that is sine theta, that is w over 1 sine theta, that is w over 1. So here, that is equivalent to 1 minus w square. So we will be using that later. Okay? So therefore, we will have the integral of w square, that is sine square theta. dw, that is cosine theta d theta. Okay. Over, okay, the square root of 1 minus w square sine square theta. And so sine square theta cosine theta d theta over 1 minus sine square, that is the square root of cosine square theta, wherein the integral of sine square theta cosine theta d theta, cosine square theta, square root of that is equal to cosine theta. So we can cancel cosine theta and cosine theta. So we can cancel that one. That's the reason what remains is the integral of sine squared theta d theta. Okay. So the integral of sine squared theta d theta, the powers of sines and cosines. So we are going to apply that one. That would be equal to, that is even. So we will have 1/2 the integral of 1 minus cosine 2 theta d theta. Okay. So therefore, you will have 1/2 the integral of d theta minus 1/2 the integral of cosine 2 theta d theta. Wherein our u here, cosine u. So u here is equal to 2 theta d theta. du is equal to derivative of 2 theta, that is 2 d theta. So we will have here equal sign. So we will have, okay, 1/2 d theta minus 1/2. Okay. So we have here cosine 2 theta 2 d theta, that is our du. So we multiply here 2. So multiply outside 1/2. So, okay, as a continuation, we have 1/2 d theta minus 1/4 the integral of cosine 2 theta times 2 d theta. So we have a form of cosine u du. So we will have, so the integration for that would be equal to 1/2 theta minus 1/4 the integral of cosine u du, that is sine 2 theta. Okay. Plus c. 1/2 theta minus 1/4 sine 2 theta, that is equivalent to 2 sine theta cosine theta plus c. So that becomes 1/2 theta minus 1/2 sine theta cosine theta plus c. Okay, as a continuation, we have w is equal to sine theta. So the equivalent triangle for that, we have 1, we have w, then you will have the square root of 1 minus w square. So therefore, by trigonometric substitution, 1/2 theta minus 1/2 sine theta cosine theta plus c. Theta, that is 1/2. Theta is equivalent to arc sine W minus 1/2. Sine theta is W. Cosine theta, that is the square root of 1 minus W square over 1. So, therefore, we are going to continue this solution. Okay, as we continue, we stop here. We have W squared over 2 arc sine W minus the integral of W squared over 2 dW over the square root of 1 minus W squared. So, okay, we are going to continue with our solution. We have derived now the answer for W squared over 2 dW over the square root of 1 minus W squared by using trigonometric substitutions. Okay, hence W squared over 2 arc sine W minus 1/2. Then we have 1/2 arc sine W minus 1/2 W, the square root of 1 minus W squared plus C. So our common here is 1/4. So we have W squared over 4 divided by 2. So you will have 2W. 2W squared arc sine W minus 1/4 arc sine W plus 1/4 W, the square root of 1 minus W squared plus C. So common is 1/4. So you will have 1/4. So what remains, that is 2W squared minus 1 arc sine W plus 1/4 W, the square root of 1 minus W squared plus C. So this is now our final answer. Okay.